multiple choice graphing problems. And for those of you who might want to look at the sample exams that are on our math department webpage, if you've been looking through those already, you may have noticed that the sample exam 2s don't quite line up with what we're doing because the sample exams that are on the math department webpage are for the residential courses that use a different book and the topics are in a different order. So the half of that exam is stuff that's in our Unit 4. So what I will do is send out an announcement today, just reminding everybody about the exam, and then also giving a list of sort of the relevant sample exam problems on the math department webpage off of sample exam 2 and the final exam, so that you're not working on stuff that's not really relevant to our midterm exam. Okay, with that out of the way, let's take a look at this vertical asymptote problem. The nice thing about doing graphing problems with multiple choice is that you don't really have to graph the entire function. Like here, we don't want to graph out the entire secant function. We just want to understand where the vertical asymptotes occur. Okay, so first off, when we're trying to find vertical asymptotes for any trig function, so a tangent, cotangent, secant, or cosecant, I usually recommend first writing your trig function as a fraction, so writing it in terms of sines and cosines. And then remembering that the vertical asymptotes occur when that denominator is equal to 0. Okay, so we want the cosine of 6x minus 3 pi to be 0, because then the secant is going to not exist. We'll have a vertical asymptote there. Okay, so now we'll think, and at this point you could just plug all your answer choices in and see which one makes the cosine equal to 0. Like for example, if we plugged in x equals pi over 6, we'd have cosine of pi minus 3 pi is cosine of negative 2 pi, which is 1, because it would be coterminal with 0. Okay, so that one's not a correct answer. So, but if we think about it, for cosine to be 0, we need 6x minus 3 pi to be some multiple of pi over 2. We need it to be on the y-axis. And therefore, we need 6x to have a denominator of 2. We need it to be like a pi over 2, so that when we subtract the 3 pi, we still get a pi over 2. And for choices B, C, and D, 6x is going to be a whole number multiple of pi, because it's going to cancel out the denominator of 2, 6, and 3. However, if we look at answer choice E, (6x minus 3 pi) is going to be 3 pi over 2 minus 3 pi is negative 3 pi over 2. Okay, so then the cosine of 6x minus 3 pi is the cosine of negative 3 pi over 2, okay, which is coterminal with pi over 2. So the cosine is going to be 0. Okay, so in this case, pi over 4 is going to be the value of x that will make cosine of 6x minus 3 pi equal to 0. So there, the secant is not going to exist. Okay, and you will not have a point there, you will have a vertical asymptote. Yeah, so that's the idea. You could take all the answer choices A through E and just plug them in to the cosine or the secant and figure out which one causes the secant to not exist or causes the cosine to be 0. That would also be acceptable. But I find that students often struggle with these sorts of problems where I'm asking for the vertical asymptote and I'm giving a bunch of x's. So there you just want the denominator to be 0. I can also ask for x-intercepts where the numerator equals 0. So again, you're just taking those x values and plugging them in and identifying where, either the function equals 0 or the function does not exist. Okay, so now let's do a couple other graphing problems here. We'll do some sine and cosine problems. Okay, so this problem just asks you to identify some features of a graph given the equation. Okay, so here we have y equals 2 times the sine of x plus pi plus 1. So we want to find the period, range, and phase shift. Okay, so first off, our period is just going to be 2 pi because we don't have anything multiplying the x. Remember, the thing that multiplies the x tells you what your period is going to be. The period is 2 pi over b. Okay, so we can eliminate the answer choices with a period not equal to 2 pi. Our range, okay, so we see that our amplitude is going to be 2 because we have a 2 times sine. So ordinarily, the range would go from -2 to 2. But we also have a shift up by 1 because we're adding 1 to our function. So that's going to add 1 to our range. Our range will be -1 to 3. So that eliminates answer choice E. Finally, we need to figure out, is the phase shift negative pi or positive pi? So remember, a phase shift of negative pi is a phase shift to the left. A phase shift of pi is a shift to the right. Okay, and now we note that we're adding a positive number to our x. So when we add a positive number to our x, that's going to be a leftward phase shift. Okay, so that left phase shift is going to be a phase shift of minus pi because we're adding pi to our x, and it's always the opposite of what we're adding to our x. So in this case, the phase shift would be negative pi. Okay, so for this one, hopefully getting the period and the range is pretty straightforward. Getting that phase shift is a little trickier. So just remember that subtracting from x is a positive phase shift, adding to x is a negative phase shift. So it's always the opposite of what you would expect, and the opposite of intuition. Okay. Yeah, so note again for that last problem, we didn't have to do any sort of graphing. We didn't actually have to sketch the graph out. All we had to do was, identify those graph features from the equation itself. Another type of graphing problem you may see is matching a graph to an equation or matching an equation to a graph. I think equation to graph is a little bit easier. So you may be given an equation and then be given like 4 or 5 graphs you have to match that equation to. The other way to do it, which is a little bit trickier, is like this, where we have a graph and we have to match it to an equation. Yeah, this is harder because for example, with a graph like this, we don't know for sure if this is a sine or a cosine. Just looking at it, it could be either. So we have to sort of eliminate the incorrect choices. So I'm going to start this one by looking at our amplitude and our range. Okay, so our amplitude, note, is 2. So this is going to be either a times the sine of bx minus c plus d, or y equals a times the cosine of bx minus c. And again, I always like to do bx minus c. If you prefer to do bx plus c, that's fine. It's going to be a sine or a cosine. Since the amplitude is 2, a has to be plus or minus 2. So it could be flipped upside down, but the absolute value of our A has to be 2, because that amplitude is 2. Since we go from -3 to 1, that's a height of 4, and half of that is 2. So that eliminates choice E. And next, we see our range is -3 to 1. And we can see from our graph the fact that this dashed line at y equals -1 would ordinarily be the x-axis if our graph was not shifted up or down. We can see from our graph here that this was shifted down by 1 unit, because instead of going from -2 to 2, it's going from -3 to 1. Okay, so that's a downward shift by 1 unit. So our D is -1. So we're looking for functions or equations that have 1 subtracted from the sine or cosine. Okay, so that's going to eliminate A and B. Okay, so C and D are the only ones that have a 2 times the sine and cosine and have the -1. Okay, so once you get down to just a handful of choices like 2 or 3, at that point, a lot of times it's easier to just start plotting points. Okay, so for example, let's take a look at our y-intercept. Okay, so the point 0, -1 is on our graph. So let's just plug in x equals 0 and see what happens with each of our graphs here. Okay, so we plug in x equals 0. We're going to, in answer choice C, we're going to have 2 times the cosine of 0 minus 1 is 2 times 1 minus 1 is positive 1. Okay, so if this were 2 cosine of x minus 1, we should have a point at 0, 1, okay, which we do not. And indeed, for answer choice D, if we plug in x equals 0, we get 2 times sine of 0 is 2 times 0 minus 1 is -1. So the 2 sine x minus 1 is actually the equation that has a point at x equals 0, y equals -1, which is what we need. All right. Let's do one more graphing problem here. Let's see how we're doing on time. Okay, 13 minutes left, so I want to do a couple multiple choice identity problems as well. All right, so let's take a look at a non-sine or cosine graph. So again, this is a graph to an equation. So when I think about the things we did in the last problem, where we can kind of plot points, we can look at some of the graph features and go from there. This may be difficult to see, but this is 1, 2, -1, -2, and then this is 1, 2, 0, 1, 2, 3, -1, -2, -3, -4, and so on. Okay, so each of these numbers is an increment of 1. Okay, so first off, this shape suggests either a secant or a cosecant graph. So B is out. Okay, this is not a tangent graph. So this is either A times the secant of bx minus c plus d, or A times the cosecant of bx minus c plus d. So next, let's take a look at the period, because that's something that's really easy to identify on this graph. Note that one period, if it starts at x equals 0, it's going to end right here at x equals 2. Okay, so here the period is just 2, so it's not 2 pi, it's just 2. So each of those ticks is a 1, it's not a 1 pi. So we have 0, 1, 2. For a secant or cosecant, the period is going to be the same as its reciprocal function. That is to say, the period is going to be 2 pi over b. And therefore, b has to be pi. So in other words, we are looking for either a secant or a cosecant with a pi times x. Okay, so that eliminates answer choice C. So now at this point, I would probably just start plugging points in to try to eliminate some other answer choices. So again, let's take a look at the y-intercept. So the y-intercept is going to be, in this case, 0, 2. And I just plug in x equals 0 and see which one or ones of these have a y value of 2. And we'll eliminate any incorrect ones. And then if there are no other possible correct answers, if we don't eliminate all but one, then maybe we can pick a different point like 1, negative 2, for example. Okay, so let's plug in x equals 0. We'll start with answer choice A. So y is going to be 2 times the secant of 0, which is 2 times 1 over the cosine of 0, which is 2 over 1, which is 2. Okay, so that one's okay. It's not necessarily the correct answer, but we cannot eliminate it. Okay, looking at answer choice D, y would be 2 times the cosecant of 0, which would be 2 times 1 over the sine of 0, which would be 2 over 0, okay, which does not exist. Okay, so our first answer choice here has a point at 0, 2. Answer choice D would have a vertical asymptote at x equals 0. Okay, and that's not the case. Okay, so D is out. Similarly, E would be out because we'd again have cosecant of 0, which does not exist. Okay, and therefore, the only answer choice remaining is answer choice A. Okay, and that is really the advantage of doing graphing problems with a multiple choice exam. You can just plot some points and eliminate answer choices that do not have the point that you need to have on it. So you don't have to go through the struggle of graphing, every single equation, and you shouldn't like stare at the equation and stare at the graph rather and try to figure out what equation would fit that graph. What you should do is figure out some of the numbers in that equation by using things like amplitude, range, period, vertical shift. Phase shift is tricky because if you're dealing, say, with sines and cosines, depending on if it's a sine or a cosine, the phase shift will be different. So that one's a little tricky. I would not, try to get the phase shift. But what I would do is once you get some of the easy numbers like your A or your B or your D, or the ones that give you your period or your amplitude or your phase shift or your vertical shift rather. And then whatever you have left, start plugging in points, plugging in x values, and see which ones have the points that you need to have on your graph. Okay, let's do a couple of identity and formula problems now. So this first formula problem or identity problem rather, is really very straightforward. I picked this one because it would be very easy to get tricked into trying to do a Pythagorean identity because we have that tangent squared minus secant squared. But instead, we want to observe that the denominator is tangent plus secant, and our numerator is a difference of squares. So we can actually factor the numerator as tangent plus secant times tangent minus secant. Remember, this is another method we can use sometimes to simplify trig expressions. We can factor the same way we do with algebra problems. And in this case, we would have a factor of tangent x plus secant x on the top and bottom that cancel, and we'd be left with tangent x minus secant x. That's just a reminder that, if you do see a difference of squares, and you have, something that maybe looks like one of the factors in the denominator, you shouldn't jump right to doing a Pythagorean identity. You may also want to try factoring to see if you can cancel out any common factors. So finally, let's do 2 formula problems. Okay, so here we're told that the terminal side of angle alpha lies in quadrant 1, and the terminal side of angle beta lies in quadrant 4. Okay, if sine of alpha is 2/3 and cosine of beta is 3/5, which of the following is the value of the sine of alpha minus beta? Okay, so recall that the sine of alpha minus beta is, and again, this would be on your formula sheet, but just to have it here, it's going to be sine alpha times cosine beta minus cosine alpha times sine beta. Okay, we're told that sine alpha is 2/3, cosine beta is 3/5. So we need to find is cosine alpha and sine beta. And here we'll use the information we're given. We have a first quadrant right triangle for alpha, and that's going to have an x value of square root of 5 by the Pythagorean theorem, because 2 squared plus x squared is 3 squared, so x squared plus 4 is 9, x squared is 5, or x is the positive square root of 5. Okay. And therefore cosine of alpha is square root of 5 over 3. Looking at beta, beta is a fourth quadrant angle, so our y is going to be negative. We have a hypotenuse of 5, we have an x of 3, so our y has to be negative 4. And therefore the sine of beta is negative 4/5. So that's going to give us 6 over 15. Minus signs cancel, so we have plus 4 square root of 5 over 15, or 6 plus 4 square root of 5 divided by 15. Answer choice A. Okay. So again, that one is not too bad. You do need to draw your right triangles or use the method of your choosing to get the cosine of alpha and the sine of beta using the information given. But this is a problem that we've been doing since the beginning of chapter 1. Given a quadrant and a trig function for an angle, find the other trig functions. The only thing that's different here is we're finding trig functions of 2 angles and then putting those trig functions into a formula. And to finish up, okay, this one, this is actually a really nice problem because it requires you to use multiple formulas. So here we're told that alpha and beta are 2 angles such that cosine of alpha is equal to sine beta, and we want to figure out how to simplify cosine of alpha minus beta minus cosine of alpha plus beta. And so what I'll do here first is write out cosine alpha minus beta and cosine alpha plus beta using sum and difference formulas. Okay, so cosine of alpha minus beta is cosine alpha, cosine beta, plus sine alpha, sine beta. Okay. And then the cosine of alpha plus beta is cosine alpha, cosine beta, minus sine alpha, sine beta. And so again, that's just reading off our sum and difference formulas for cosine off of our formula sheet. Okay, so then we have cosine alpha, cosine beta, minus cosine alpha, cosine beta. That cancels. We have sine alpha, sine beta, minus negative sine alpha, sine beta, or 2 sine alpha, sine beta. Okay, sine alpha, sine beta plus sine alpha, sine beta, because the minus signs cancel out. Okay, and then we're given this additional fact that the sine of beta is equal to the cosine of alpha. So we can rewrite this as 2 sine alpha, cosine alpha. That's just for this problem because we're given that additional bit of information, sine beta is equal to cosine alpha. And then we need to recognize 2 sine alpha, cosine alpha as a double angle formula, and this is the double angle formula for sine. This would be the sine of 2 times alpha. Okay, so that's a good question. So notice when proving identities, I sometimes use 10 plus steps in ALEKS when the explanation will use 6 or so. So a number of steps that when reached, I should say, there probably is an easier way to simplify. That's a good question, and yeah, that's something that I talked about a little bit with that first identity problem. That sometimes ALEKS will usually try to pick the most or one of the most efficient ways to do an identity, whereas I tend to focus more on recognizing patterns, and when you see a specific thing, you use a specific technique. I would say that if you're doing an identity, I'm not going to give you an identity on an exam or a quiz. It's going to take more than like 6 steps at the most, I would say. So I would say certainly if you're starting to approach like 10 steps on like an exam or a quiz problem, you may want to go a different route. If on ALEKS, if you're getting to like 12, 13 steps, you may want to go back and think if there's an easier way to do it. At the same time, if you're if you're working through the problem and you're getting to the end, it doesn't really matter so much to me if you're picking the most efficient method or not. So yeah, I would say, if you get to like 12 steps or so, the biggest thing is if you start to go around in circles. If you start using some of your basic identities or your formulas and you end up back at a previous step, then that's a big red flag that you've gone down the wrong path. But other than that, if it's taking you less than say a dozen steps, it may not be the most efficient way to do it. But if you're sort of like recognizing patterns and doing the same thing whenever you see that pattern, I'm more concerned about being able to do that than trying to pick the absolute most efficient way to do any single problem. Oh yeah, no problem. All right. Any other questions today? All right. If not, then I think we can call it today. Call it a day. So remember to get signed up to take the exam. I will send reminders out again. Talk about the relevant sample exam problems. Please make sure that you get working on Unit 3 if you need a little bit more time to finish up. and I will no, I will be off next week because it is Thanksgiving break, so I will not be in the office, which means I will have some time to do some, some additional web sessions next week. So I will start in on Unit 4 next week and talk about some of the things in there. Unit 4 is going to start out with some of the hardest material with inverse trig functions and trig equations. And then once we get to the end of Unit 4, we're going to be doing some stuff with triangles. That's actually going to be some pretty, don't necessarily want to say easy, but it's going to be a lot easier than the stuff that we've been working on recently. It's law of sines, law of cosines, and areas of triangles, which if you took high school trigonometry, you may have seen a lot of that already. So it's going to be sort of a nice way to finish up the course because it's not quite so algebra and formula based as what we're doing now and in the beginning part of chapter 4. Everybody have a good day, and I will be in touch.